The subject of Math 221, aka Calculus 1, is functions with one real variable. Do you know enough about functions? Let's do a problem together. Let k be the function with k of x equals x squared, whose domain is all negative real numbers. Find the domain of k inverse and draw the graph of k inverse. Before we solve this problem, let's talk about inverse function first. There are many ways to express a function. For example, we can use a formula, f of x equals x squared. We can also draw the graph of a function. For example, the graph of x squared is called a parabola. We can also think of a function as a map from numbers in the domain into the numbers in the range. For example, our function x squared maps 0 to 0, negative 1 and 1 both to 1, negative 2 and 2 both to 4, etc. When I visualize an inverse function, I first visualize the function as a bunch of numbers on the left mapped to a bunch of numbers on the right with those arrows going from left to right. And then I visualize the inverse function by reversing the direction of all the arrows. Then I remember not every function has an inverse function. Only functions that are one-to-one have inverse functions. Our example here, negative 3 and 3 are both mapped to 9, and we are trying to reverse the arrow. We don't know which number, negative 3 or 3, should 9 be mapped back to. So x squared does not have an inverse function, because for most of the numbers in the domain, they are mapped 2 to 1 into the range, not 1 to 1. In conclusion, a function has an inverse function if and only if it is 1 to 1. Now let's come back to our original question. K of x equals x squared, but the allowed input x can only be negative numbers. Before I try to find a formula for the inverse function of k, I'd like to make sense out of this function k. I usually start by graphing the function. I'd like to know whether this function is even one-to-one to start with. The graph of k is just the part of the graph of x squared that stands on the domain of all negative numbers. We can see from the graph that k is monotonically decreasing, so it is indeed a one-to-one function. So it makes sense to talk about its inverse. It's actually much easier to graph its inverse first. Just make a copy of the graph of k, and then denote the vertical axis by x and denote the horizontal axis by y. Voila, now we have the graph of k inverse. I know it looks weird because usually we have y on the top, x on the right, but technically it is correct, and I will explain why. If we look at the graph on the left side, we know how to find the output y from the input x using the graph. For example, if x is equal to negative 3, we can trace the blue arrows and find y equals 9. Now, if we look at the graph on the right side, we also know how to find the output y from the input x. For example, if the input x equals 9, we can follow the red arrows and trace to the output y equals negative 3. I hope this more or less demonstrate that the graph on the right side is technically the graph of k inverse. But we are not used to x being the vertical axis and y being the horizontal axis. So what I will do is take the graph on the right, the axis and the graph of the k inverse, take the whole thing and rotate it around the blue axis 180 degrees so that x will be horizontal and y will be vertical again. Or we can just do what we usually do. If we look at the graph on the left side, we take the graph of k and flip it about the blue axis, and then we will get the graph of k inverse, which is in red. From the graph, it is also obvious that the domain of k inverse is all positive numbers. Now let's find the formula for k inverse. Recall that k of x equals x squared, where the domain is all negative numbers. Next, we denote the output of the function k by letter y. Then we switch x and y, because for the inverse function, input becomes output, output becomes becomes input. Then we solve for y equals plus or minus square root of x. If we have two options, then we don't really have a function. Luckily, we know y is less than 0, so y equals negative square root of x. And the domain for this inverse function, we have seen that from the graph earlier, which is all positive numbers. So someone might ask, can we figure out the domain without the graph? I don't think so. You really need to see the graph in order to figure out the domain of the inverse function. So the formula for K inverse is negative square root of x for x greater than 0.